Alrighty, on this video I just want to give us a quick look at taking care of rationalizing the denominator when we have binomial terms, okay? What we need to realize is when I have a binomial on the bottom with a radical, something like 1 plus 3 plus radical 5, we used to just multiply by radical 5, but if we multiply by radical 5 to get rid of the denominator, we're going to get radical 5 on the top, which is fine. We get 3 radical 5 plus 5. Noticing that doesn't get rid of the radical. Okay, what we're going to do is, to take care of something like this, we're going to multiply by the conjugate of the bottom. The top doesn't matter, just the bottom. Okay, the conjugate is the same as the term before it, except the sign is different in between it. So whatever's down there, that's the conjugate. So the conjugate, notice that the 3 is the same, the radical 5 is the same, symbol is just different. Alright? This, the reasoning for it is, if you multiply by this, oops, let's do it again, minus radical 5, you're going to see, normally you have to first outer inner last this. You got to distribute this. But when you distribute, the top is easy. The bottom, 3 and 3 are 9. The outsides are minus 3 radical 5, and the insides are plus 3 radical 5. Well, that's a nice little thing. And by the way, this is minus 5. Radical 5 times radical minus 5. These go away. And that will always happen if you use the conjugate. That's the whole point. So really, it's just the 3 and the radical 5, and we square them and subtract them. So it's 3 minus radical 5 all over 4. Noticing that we don't have a denominator. Okay? So, let's do a couple of practices. What's the conjugate of the following? So what's the conjugate of these? That's 4 minus radical 2. What's the conjugate of this? It's 1 plus radical 13. The conjugate of this, still radical 5 front, 5 plus 5. And then this one right here is radical 11 minus 6. Okay? Notice how the signs have just switched to their opposites in between them. Alright? Just to let you know, if there was a negative in front of it, like negative 1 plus radical 13, this becomes negative 1 minus radical 13. Okay? So no worries. And if you multiply them out, you're going to realize that this is 16 minus 2, which is 14, 1 minus 13, which is negative 12, 5 minus 25, which is negative 20, and 11 minus 36. Okay, so you can multiply them out. You'll see they always become whole numbers. If you do it right, you will not have any radicals left. Okay, so let's rationalize the denominator here. So you're going to multiply by its conjugate, 2 plus radical 3. If we do it to the bottom, got to do it to the top. 2 plus radical 3. Distribute. 5 times 2 is 10, plus 5 radical 3. The bottom is 4 plus 2 radical 3 minus 2 radical 3, so those go away. Minus, no, radical 3 times radical 3 is 3. So look at that, that's 10 plus 5 radical 3 all over 1. So you don't even need the 1 there if you do that. Okay. Over here, we multiply by the conjugate. Well, that's 4 plus radical 10. All you do it to the top. 4 plus radical 10. Distribute. 6 times 4 is 24. Plus 6 times radical 10 is 6 radical 10. The bottom, 4 times 4 is 16. 4 minus 4 radical 10 and negative 4 radical 10 go away. Minus the square root of 100. 10 times 10 is 100, which is 10. That's 24 plus 6 radical 10 all over 6. Now for the real question, does this simplify? And it does. To divide these, you have to go into all the coefficients in order for this to work. Does 6 go into 24? Yes, it does. It's 4. 6 go into 6? It does. It's 1. Radical 10. So you divide this by 6, that's 1. This by 6, it's 1. This by 6, it's 4. We're done. No fraction. That's even better. This one right here doesn't matter. Radical 15 plus 3. Do it on the bottom and top. Top becomes 4 radical 15 minus, or sorry, plus 4 times 3, which is 12. The bottom, radical 15 times radical 15 is 15. Minus 3 radical 15 plus 3 radical 15, those go away. Minus 9. 4 radical 15 plus 12 all over 6. Does anything go into all of these? Yes, you can divide all of them by the number 2. So if you divide this by 2, it's 3. Divide this by 2, it's 2. Divide this by 2, it's 6. I get this answer. 2 radical 15 plus 6 all over 3. That is actually our final answer. Okay? You want to start doing this. Well, you cannot do that. That's a no-no. Got to go into all 3 of them. Now, people could reduce this to separating them, which is a true statement. That's 15. And then that's 2, but we like it as one fraction, okay? So our final answer is just this without those little lines there. Okay, final answer. 2 more to go is practice. Here we got a little bit more of a problem because we have a binomial on the top. Well, the conjugate of the bottom is 4 plus radical 11. We do not worry about the top. It's still 4 plus radical 11. Can only multiply by a form of 1. The top, we have to actually distribute out. 4 times 1 is 4, plus 4 radical 11, plus 1 radical 11. Radical 11 times radical 11, plus 11. Right? The bottom, 4 times 4 is 16, plus 4 radical 11, minus 4 radical 11, minus 121 squared, which is square root, which is 11. Clean up the top. That is 5 with a 15 plus 5 radical 11 all over 5. Does something go into all 3 of those coefficients? Yeah, 5. So it's 3 plus radical 11. Our last one over here may look pretty easy, and it probably is. What's the conjugate of the bottom? Well, it's radical 7 plus radical 3, which happens to be the top. Okay? You still have to FOIL it out. Okay, let me write that a little cleaner. Radical 7 plus radical 3. Okay, don't just square the term. Radical 7 times radical 3, or radical 7 times radical 7 is 7. Radical 7 times radical 3 is plus radical 21, plus radical 21, plus 3. The bottom is 7 minus 3. The top is 10 plus 2 radical 21 all over 4. Something going to all of them? Yeah, 2. So it's 5 plus radical 21 all over 2. Does anything simplify 21? 7 and 3 can really help us, okay? So there you have binomial denominators rationalized.